Hello everyone and thank you for joining. I am Angela van der Plas and I am Manager Real-World Evidence and Epidemiology at Philip Morris International. Today I will be presenting results from our time trends analysis on hospitalizations for COPD and ischemic heart disease in Japan before and after the introduction of heated tobacco products. Smoking affects the health of individuals and populations. It has been estimated that if trends continue, 1 billion lives will be lost to smoking in the 21st century. Tobacco harm reduction refers to strategies that reduce the health risk associated with smoking, which may involve the continued use of nicotine-containing products. Heated tobacco products heat tobacco instead of burning it, and the absence of combustion translates into a reduced exposure to harmful and potentially harmful constituents. Philip Morris International's heated tobacco product is currently marketed as IQOS in over 50 countries. While these products are not risk-free, they have the potential to give smokers the chance to switch to better products. In this talk, we will present results of our first real-world evidence analysis. As heated tobacco products become available in different markets, it is important to assess their impact on the health of the individual and the population as a whole. Real-world data can be used to look for early signals of the population health impact of introducing novel tobacco products, for example, heated tobacco products, before epidemiological data are available. The aim of these studies was to describe the rates of hospitalizations for chronic obstructive pulmonary disease, COPD, COPD exacerbation, and ischemic heart disease, IHD, before and after the introduction of heated tobacco products in 2 Japanese databases. For these studies, we use data from the Japan Medical Data Center, which is an epidemiological receipt database that includes 7.3 million subjects. JMDC contains disease procedure diagnosis or DPC data by which the reason for hospitalization is classified under a flag, for example, main disease or causative disease, and inpatient data which are not categorized by a flag and are overall more abundant. The second database was the Medical Data Vision, MDV. This database contains hospital admissions using ICD-10 codes for COPD, COPD exacerbations, and ischemic heart disease. This database includes health claims data from over 300 Japanese acute hospitals, including records for over 20 million subjects. The hospitalizations from 2013 to 2019 were aggregated by month and year, with admissions per ICD-10 code category expressed as a percentage of the total of admissions. Different models using ITS, or interrupted time series, allowed us to test the hypothesis that the introduction of heated tobacco products is associated with change in hospitalizations in terms of the intercept, mean change, and slope, changing speed. It's also flexible for adjusting for different confounders. For this analysis, we used 2 types of event definitions. The first one was a no-flag analysis including all data, and the second one had only DPC data included using the causative disease flag for hospitalizations. The cutoff point was based on previously published sales data, and since heated tobacco products were introduced into the Japanese market late in 2014, it could be assumed that there is a 2-year lag period. Now let me show you the results. These are the data counts by endpoint by year. The study period included was from 2013 to the year 2019. Because data coverage increased substantially between 2012 and 2013. Because of the very low counts of events in the DPC data, the only analysis done using it was for the ischemic heart disease endpoint. The study period included was from 2013 to 2019 because data coverage increased 49% between 2012 and the year 2013. Both MDV and JMDC databases contain different populations. For instance, the JMDC database contains younger enrollees and a larger proportion of females than the MDV database. In terms of number of hospitalizations, the JMDC database has around 1/4 of those included in the MDV database. Additionally, due to the low number of COPD exacerbations in the Japanese population in general, we added the endpoint of COPD plus lower respiratory tract infections in order to have comparable data to that seen in the MDV database. This slide shows the MDV database analysis on COPD hospital admissions adjusted for age and sex. Using the MDV data, we see a small decline in the hospitalizations due to COPD after the introduction of heated tobacco products that was not statistically significant. This slide presents the interrupted time series model adjusting for age and percentage of females using all data for COPD hospitalizations using JMDC data. The cutoff point of introducing heated tobacco products was set at January 2017 based on previously published sales data. Hospitalization rates for COPD adjusting for age and sex were significantly lower than expected. Further adjusting for other covariates such as influenza vaccination coverage and seasonality did not alter the results. The analysis for COPD exacerbations using the MDV database showed that hospitalization rates adjusting for age and sex were significantly lower than expected. Further adjusting for the covariates such as influenza vaccination coverage and seasonality did not alter the results. This slide shows the hospitalizations for COPD exacerbations, including lower respiratory tract infections in those with COPD. We observed no significant change in trends after the introduction of heated tobacco products. We also observed a small decline in the hospitalization rates for ischemic heart disease, and although the decline was not significant, it makes sense to reevaluate this endpoint after a longer follow-up post-introduction of heated tobacco products in the Japanese market. The analysis using all data from the JMDC database found a decline in the hospitalization rates for ischemic heart disease that was not statistically significant. For ischemic heart disease hospitalizations using only DPC data, we can observe an immediate increase in the rates post-heated tobacco product introduction that was statistically significant, followed by a change in slope post-heated tobacco product introduction, which was significantly different from the expected increase in trend. The analysis of the MDV data showed a significant reduction in the rate of hospitalizations for COPD exacerbation after the introduction of heated tobacco products in Japan. Small declines in the hospitalization rates for other smoking-related diseases were observed, for example, COPD all codes and ischemic heart disease, although they were not significant. The analysis of the JMDC data using all available data showed a significant reduction in the rate of hospitalizations for COPD all codes after the introduction of heated tobacco products in Japan. The small declines in the hospitalization rates for COPD exacerbation, COPD plus lower respiratory tract infection, and ischemic heart disease were not significant. The analysis, restricted to DPC data only, showed a significant reduction in the rate of hospitalizations for ischemic heart disease. Data regarding COPD endpoints were scarce, hence no meaningful interpretation can be drawn. There was a significant reduction in the rates of hospitalizations due to COPD after the introduction of heated tobacco products in Japan, when using all data, and due to ischemic heart disease when using DPC data only. Time trends analysis focus on populations, but can be a useful tool in detecting potential associations between heated tobacco products and smoking-related diseases. While tobacco use history is not captured in detail in hospital records, this analysis detected some encouraging trends in smoking-related disease hospitalizations in Japan, which show the same trends as our previous study. Finally, there are many limitations to this type of research, such as no subject-specific data including specific exposure, and it is important to mention that the results do not indicate a causal relationship. Thank you very much for your attention.